Good evening, ma'am.
Yeah, good evening. Sir has joined, Sam?
No, ma'am. Ma'am, no, ma'am.
Okay, I will just call him.
Yes, ma'am.
Sir will join in few minutes.
Yeah.
Dear participants, sir is having some technical issues. We'll join in a couple of minutes.
Okay, ma'am.
வந்திருக்கு. தேங்க்ஸ் ஃபார் யூசிங். ஓகே. இப்போ எனக்கு ஒரு இன்னொரு ஹெல்ப் ஷேர் பண்றதுக்கு ஓகே, அதுல இருந்து எடுத்துக்கலாம் இல்லையா? இப்போ எல்லாருமே இருக்காங்களா? ஒரு நிமிஷம், நான் என்னுடைய இதை பார்க்க முடியல. என்னை பார்க்க முடியுதா நீங்க?
Yes, sir. You are visible, sir.
Okay. I am not able to see anybody. Madam, extremely sorry. Is it audible, ma'am?
Yes, sir, you are
இல்லையா?
audible.
Is it audible?
Yes, sir. Audible, sir.
Okay. Okay. Madam, shall we go ahead?
Yes, sir. Please.
Okay.
Preeti.
Already it's time.
Yes,
I'm
ma'am.
sorry, ma'am.
Yeah, Preeti,
Sir,
sir.
I'll give you
Go ahead.
and then we can proceed, sir.
I didn't get you.
I'll
A
give an
small-
introduction, sir. Start, sir.
Yeah, please go ahead. Go ahead.
Wonderful evening, everyone. This is Preeti Rose, full-time research scholar under the guidance of Dr. R. Shanti, ma'am, Department of University of Madras, Department of Commerce, and Madras University Commerce Alumni Association. I would like to welcome a resource person for this evening, Professor D. Lazar, sir, Department of Commerce, Pondicherry University, for the webinar on Harnessing Excel for Statistical Analysis in Research. Before moving to the session, let me introduce about our resource person to the participants present here. Professor D. Lazar, sir, is a distinguished faculty member at the School of Management, Pondicherry University. He has significantly contributed to academics and research over the past decades and has previously served at Loyola College, Chennai. Sir has gained extensive expertise as a qualified cost accountant with a professional diploma in management. Professor Lazar, sir, has been recognized with the prestigious Best Researcher Award for his outstanding contributions to social science research. His international experience includes a deputation to Bhutan under the TCS of Colombo plan by the Government of India. Professor Lazar, a prolific academic
entire
person,
screen
has
கொடுத்துலாம் சார். கொடுத்துட்டு எந்த
four
இதுல
international
PPT ஷேர் பண்ண
conferences
போறீங்களோ அதை
on
கிளிக் பண்ணிக்கலாம் சார் பவர் பாயிண்ட்.
published 35 research articles, 6 edited volumes, and
நான்
9 monographies.
கொடுத்துட்டேன் சார்
And
உங்களுக்கு
has
மேக் நான் பிரசன்ட் நான் மார்க்.
research project.
எஸ் சார்.
Recently, Sir has honored with the MCX IIMA Award for Excellence in Research along with a prize of rupees 1 lakh for
ஷேர்
co-authoring a paper titled Gold Smuggling in India. So this stands on to his status
அந்த
as
எக்ஸல்
an
கிளிக்
eminent
பண்ணா உடனே அது ஷேர் ஆயிடும் சார்.
in his
எக்ஸல்
We welcome you, sir, for this webinar, and you may now take over the session, sir.
சார் மைக் ஆன்.
So please turn on your mic, sir.
Whether Excel sheet is seen by you?
Yes, sir.
எஸ் சார்.
Yes, sir.
Yes.
Okay. Okay. Then it's okay. Now, let me thank Dr. R. Shanti, head of the Department of Commerce, University of Madras, and other research scholars for having taken effort to attend to this and for having organized this particular webinar. I'm so happy, and let me apologize. WebEx was not there. There was some problem in connecting it. Anyhow, we will try to make it up what is required. Just 1 minute. சார் ஒரு வெபினார்ல இருக்கு, கொஞ்ச நேரத்தில் கால் பண்ணட்டுமா? 8 minutes நான் கால் பண்றேன். ஓகே. So let me thank the other department as well as other members. Let me, without much wasting time, let me get into this. Now, this is the data which I have collected from my class, just to share some of the information. You could find out the registration number, name. These are the details which are there. I thought of using this data to basically to help you to understand. Now, before we get into the data for analysis, what is expected by you is to, in your Excel sheet, you go for using the add-in option, go to the file, you go to the file, then there is an option here at the end. When you click that, there will be a left hand side, you will find general formula proofing. There is something called add-in. You can get that add-in. When you click that add-ins, there is something called analysis tool pack. VBA is not required, but you can go for a analysis tool pack. Click it and then say OK. So again, if you want, I'll repeat. Go to the file. Left hand side, you will find options. Click it. Then again, left hand side, you will find add-in. Click that add-in. There will be a lot of things to be added. Analysis tool pack, which is required for this particular class. Another one which we may use, not now, today it may not be possible. There is something called solver add-in. Solver also you can try to bring in. Maybe later on, when we go for optimization model, we can use that. Okay, save OK. Then if you want to check whether it has come into your system, go back to your Excel. There is something, in the menu you will find data. Under the data, at the right end, you will find data analysis and solver. So whatever data you have got in the Excel, you can try to go for getting the add-in. Once you put that add-in, then you will get this data analysis and solver. Is it all right? Any help is required? Once we have done this in the Excel, now you can interact so that I will know that whether I am going the right speed. Is it all right for you to get the add-in?
Yes, sir.
Okay. Now go to the data. Whatever data you have got, you can go to the data. Here you can just observe it. Here a lot of quantitative data as well as qualitative data are there. For example, sex is there, male and female. We may not be able to use as such. Therefore, what I have done is I have put a sex dummy. I have converted that data. In case if you have anything of this type, you can use a dummy variable. That we will come to that little later. But now you look at the data which are all there, like age, weight, height, 10th marks, 12th marks, degree percentage. Additional qualifications, so not a required one now. First year grade point average is there. Whether Oscillus or day scholar, I have used a dummy here. That I'll come to that later. Then monthly pocket money, how much they are getting, how much savings they have got till today. Then other variables, other things you can leave it. And then come to the whether houses in rural area or urban area, rural and urban, again I have converted that into dummy. We will use the dummy later. The number of members in the family, monthly family income, in fact, it is obtained from everyone. Finally, monthly salary expected in case if they join for a job. These are the data which are all there. Now, to find out whether first of all, your quantity, I'm looking at the variables and quantitative data. I'm not looking at the qualitative. Look at the quantitative data. If you have anything, you can go for it. Let us assume you may have to check your data whether the data is in order or is anything outlier. Here, everything will be in order because I have removed all the outliers. Before I came here, I have done the little cleaning of the data. So let us imagine how to check this whether data are not having outliers. I am selecting the weight, or let me take the height and select all the data. Go to the insert. There is a chart here. There is something called scatter diagram. I'll put this scatter diagram. You will find this picture, which means almost they are around the place. If you want to see the change, what I do is, without, let us imagine here itself, I'll try to go for changing the data. Instead of 169, let me put 250. Okay, I will just change the data 250. After that, now I'll select the data, go to insert, put the diagram, scatter diagram, look at where the 250 point coming in. This is a data point which is quite deviating from the other one. When you have a data of this type, whenever there is outliers, the results what you are going to get will be spurious. Results will not be perfect. Therefore, check all your data first, whether any outliers are there. If there is outlier, then your duty is to clean up the data. So what I did already, I have done it. That's why it came perfect. So I'll go back to this. I'll try to undo it so that original value will come. $169. So now when you have this data, things are quite within a particular range. There can be changes. Same type I have done it for all other data. I have already cleaned it. So you can check your data first of all whether any outliers are there. If there is any outlier, try to set right it. Maybe you can try to check it through the scatter diagram. Dummy variable, there is no need to check it, but all other variables you can try to check. Okay. Shall I go to the next stage?
Yes, sir.
Now, once you were confirmed whether your data is perfect, your data is within the range, it is not having any outliers, then next step is you can go for the statistical analysis. One of the statistical analysis is the graph charts. Again, I'll take the, let us say 12th mark or degree percentage I'll take. You can select the data, go for insert. Always there will be a line graph that will tell us insert. You can take a line graph here. Of course, you can click here. If you want to give a chart title, you can use the chart title. This is the 12th mark. You can simply type there. or degree percentage. So you can get that. Okay. Then if you want more changes to be done in this graph, if you want whatever figures you need, keep the cursor on the graph itself, click it. After clicking it, have a right click. It will ask whether to add the data labels. You can say add data labels, then all the figures will come, but it will be quite clumsy. Therefore, there is no need. If you don't want it, again keep the cursor there on the graph itself, or the uh, curve. Go for changing it. You can remove the numbers labels from there, because it will be quite clumsy. If you want, you can have it. If at all you have a big picture, all these values will help. If you want to change the data labels in a different form, you can do it. Like this, it will give you array marks. All this play, you can do it. Okay. I have removed the labels. I just put a control Z. Automatically, it will go to the backward. Okay. Now, if at all you want to change the picture, whatever you want to do it, of course, you must be comfortable with that. You can go for formatting the entire area. So one of those is this. Either you can do a line graph, or you can go for any other format which you need. Let us assume you are interested in this type. You can put a graph, and title you can change it. Whatever you want to do it, you can do that. So this will give an idea. So first important statistical analysis is to go for using the charts or graphs. You can have a multiple graphs, a multiple bar, or single bar itself, multiple what you call variables. You can show it. It is possible. Another important things in statistics is descriptive statistics. I'll use the 12th mark. I have selected the 12th mark. Let us assume you wanted to have a descriptive statistics. Or if you want, I'll use all this, all the quantity variables. I have selected all the quantity variables or simple variables. Now I have selected it. Go to data. There will be data analysis, right hand side. Click it. It will give you option whether you want ANOVA, single factor or two factor, correlation, covariance. There is something called descriptive statistics. Okay. Save OK. It will ask for the range. That is the time you are supposed to select it. I'll cancel it and then I'll come back. So I'll go back again to the data analysis, descriptive statistics. Now it will ask for the range in which I'll have to give whatever variables I want, I'll have to give it. So now I am selecting it, all the variables. Now labels are to be shown in the first row. I want them to show it in a separate new work, the result to be shown. So the moment you say descriptive statistics, whatever you wanted will come. I'll say OK. At least one statistical option. Okay. I'll say summary statistics. Say OK. This is what going to be the result. So if you want, you can adjust it. For example, That is only a rearrangement. Because I'll be deleting this so that all the data can be together. Same. This is only a presentation for you to understand. It's not. Okay. This is the one we have got for all the variables. Now, if you want, we can think about interpreting it. How do we go about interpreting? There are about 86 students. Total is immaterial, but you are able to find out the minimum age of students in the class is 21. Maximum age is 24. On an average age is 21.87, means 22 approximately. So standard deviation doesn't have much a role here. But look at the weight. Average weight. There are students with 35 kg. There are students with 96 kgs. So how do we understand about it? So when you look at the average, 60 on average, because both boys and girls are there. If you want to do the analysis, if you want to conduct the analysis, same thing you can do it for girls separately as well as boys separately. Then you'll have more clarity. But now understand, in general, how do we interpret about the results? There is a mean 60 kilogram. There is a standard error. You take the standard deviation. Don't take the standard error. Take the standard deviation. Look at that between mean and standard deviation. Mean is 60, standard deviation is 13, which means very high deviation is there in the age weight of the students. Maybe because you have two sexes together, boys and girls together, possibly girls' weights will be lower and boys' weight will be possibly higher. So that is giving you the very high level of deviations. Variance also they have calculated. It is sample variance is 186. Kurtosis and skewness both are positive. So positively skewed and it's not very high. Skewness is there. And our kurtosis also is within the limit. So here we can understand that there is a very high deviation between in the weight of the students. When there is a high deviation, you have to be careful with the data what you are using. You cannot take as it is whenever there is a high deviation and proceed further for further analysis. So how do we really adjust this deviation? One method, what I said is divide the data between boys and girls. Then try to calculate weight and standard deviation will be quite closer. That is one way of doing it. Because we know that it's a group of people are mixed. By nature, there will be a different weight for different components. Therefore, we may have to be carefully doing it and try to go for dividing the data. You could observe same thing with regard to the height of the students. Height is 166. Standard deviation is 8. Relatively, deviation is lesser as far as height is concerned. Because 166 is the average, 8 or 9 is standard deviation. And also kurtosis, skewness is little negative. Negatively skewed, which means to the right. it is quite skewed to the right. That too, it is negative, which means when there is a negative, one set of group of people are having a weight to that particular side. Then this is are to be taken care, because you should identify the group which is skewed. If possible, you try to take them out and then try to see that. Again, one way of doing it, sex wise, you can divide them, possibly. Then look at the skewness. Then coming to the marks, 10th mark, 83 is a mean, and 12 is the standard deviation. Again, skewness also is negative, which means one group of students are having the marks one-sided. It has gone one-sided, and people are having either highest mark or high marks one section, one group. It should be a bell shaped. Instead of bell shaped, I think it is moving towards the right, which means people are having higher marks. So how do we adjust it? As I said, identify the people or divide the data based on the marks. Try to do the analysis. If at all somebody is having 70 and above, put them in one group. Below 60, in fact, you could find here minimum maximum. See that changes why it is. Minimum maximum will tell you why this type of change. Minimum marks percentage 10%, maximum 100%. So very deviation. That's the reason why 12 you are getting it. And when data is like this, you may have to divide the data group and then try to analyze it. That is a basic information you can have from the descriptive statistics. Just see whether any information you can, anything you wanted to clarify before I go to the next. Anybody? As I said, first check the data, whether any outliers are there. Once you confirm that there are, yeah, please go ahead.
Can you please repeat the same thing?
Little
Analysis
louder.
of data.
I'm sorry?
Can you repeat this one, sir? Analysis of how to get mean, median.
Okay. Descriptive statistics, how to get it. Shall I repeat it?
Yeah, sir.
Okay. Go to the data set. There is a data menu, will have a data. Right hand side, you will find the data analysis which you have brought in. Through add-in, you brought into this. Click that. It will give you a lot of options. A lot of things will be there. We'll come to that, whatever possible are required now. There is something called descriptive statistics. Say OK. It will ask for input range. I want to have all the variables, quantitative variables. So I am selecting all this age up to degree percentages. I am selecting the entire data. That is a input range. I am saying labels in first row. All the names what I have got, weight, sex, height, all those will be there in the first row. That's what I am asking. I am asking for the summary statistics. That is a statistical requirement. I say summary statistics. Then where the output should be shown, I'm asking them to show it in the new worksheet, separate worksheet. And here grouped by columns, already done it by columns. If you want, I'll do it in a row. Means the variables will come in the left-hand first column. All of the details will be there in the row. So you can change that according to your own requirement. When you say OK, the results will be there in the next sheet. Automatically the sheet will come. you can this I edited it earlier. So this is how the results will come in. Then you may have to use this basic. No, why do we do this descriptive statistics? What is the necessity of summary statistics? You need to understand the characteristics of the data, nature of the data, pattern of the data. So this will reveal what is the characteristics of the data which you are using. So it is necessary that summary statistics should be done first and then try to go for rest of this. So when you are interpreting, normally we'll have to look at the mean and then look at the standard deviation. Whenever there is a need, minimum and maximum can be considered or touched upon. Then go for kurtosis and skewness. If very high skewness is there or any signs, let us say minus is there, it indicates that towards one side the data group of people are there. So it is better try to concentrate or separate them and then try to go for the analysis so that results will be good to rely. Any doubt? Yeah. So we'll go to the next one.
Yes, sir.
Yes, sir.
Yeah. Okay. Now, same way, what I do is I'll go for data analysis. Let me do the histogram. You'll be knowing it will give you the, if you want, I can just show you the histogram. Input range, it will ask. I'll ask for the age, weight, or one variable alone I'll show you so that it will be good for you. You can understand how it will look like. I didn't click the label, therefore I'm not ticking. Suppose if the title I have clicked, the weight or height, I can say label I need to show it. I'm asking them to show the results in the new worksheet. If you want, you can ask for a Pareto graph. I'll say yes. It will go for giving you the, and then try to give you the answer for this. This is a graph. If you try to click this and go for insert and graph, you will find out what is happening. So many numbers, but this need not be a correct graph for you. We are supposed to get the bell-shaped curve. It is dividing them. It is giving you the frequency of how many are there in which group. If you want, I'll repeat again. 1 second. So data analysis, histogram. Okay. It will ask for the range. So what I do is I'll try to take the data. Let us say 10th mark or 12th mark with the title I'll take. I'll say label, new worksheet. Say I'm not asking for Pareto, therefore only single one column will be there or only one result will be there. Earlier you had two results because I asked for the Pareto. Now only one result. Earlier you had four columns. This is how the frequency is calculated, and you can go for finding it out which is dominating, which particular age or which particular size or weight or height is dominating, how many people are there in that group. This will give us an idea how to really go about doing it or interpreting it. Okay. Now, next I'll go for third one. I will go to the next one. Let us say data analysis. Let me try a correlation. Where is it? Yeah. It will ask for two variables. I'll try to see the correlation between 12th mark and degree, whether they are correlated or not. I didn't click the title, therefore I'm not asking the label in the first row. I'm asking them to show it in the new worksheet. Say OK. I'm able to see the result here. Column 1. Now, if you are confused, I'll go back. I'll get the labels. I'll get the labels so that you'll be able to understand. Data analysis, correlation, OK. I want to take the label so that so rest of the things I'm saying labels in first row. Rest of the things are same. You'll find now. So what do we interpret? 12th marks and degree percentage I compared. I wanted to see the relationship. We can very well say there is no relation between the 12th and degree marks what they have got. In all probability, what I feel, they would have extremely done well in 12th, and degree first year, they would not have done. Of course, it has not gone negatively, but it is going down to the level almost only 0.28. We are able to find out that their performance is not so good in the college, in the university. In the school level, they would have done possibly, or they would have done very badly in the school level. In college, they would have done better, possible. So, if you want, I will go for taking the few more data range. I'll try to compare what can be done. Yeah, I'll compare 10th, 12th, and degree marks. Correlation, same. I'm repeating the same. Let me see whether there's any relation with all this three. So rest of things, since you are now knowing it, I am not doing it. Tenth mark and college mark, university degree first year, absolutely no relation. It is almost zero. And 12th mark and degree at least 0.228 out of 1. So what does it indicate? What is it we get out of it? The students' performances are not having the relation to each other. Look at the 10th and 12th, 29, almost 0.29. 10th and degree, absolutely no relation. It is almost zero, I would say, which means 10th they would have done extremely well. Over the period of time, when they come to degree, the Try. Now I am going for, just so that I wanted to take age and then degree percentage.
Sir, screen is not visible, sir.
Screen is not visible?
Yes, sir.
Now only or earlier?
Just now, sir.
Now only or earlier? Sorry?
Now, just now, the screen is not visible, sir.
Now?
Only now, sir.
No, is it, you are able to see it or not? Now?
No, sir. No, we can't able to see your
No,
screen,
sir.
sir. No, sir.
Why is that? I am using the same way. Just see now.
So not visible, sir.
Why is it? I'm keeping as it is what I did earlier.
Oh, it's not visible, sir.
I'm just trying. Is it now?
Yes, sir. Yes, sir. Yes,
Are you
sir.
able to see? Okay.
Yes, sir. We can see, sir. Thank you, sir.
So correlation, you are able to understand how to
Sir.
do it?
Yes, sir.
Okay. Now what I thought, just a wild idea. Let me see any relation with age and normally we should not do it, but still out of interest, I thought I will try to see whether any relation is there with this. Input range is not combining together. It's not nearby. So the data I should have it nearby. Therefore, it is not taking it because I use the control function age and degree to be together, but it is not taking it. So if you have a columns nearby, you can click it and then it will be having a some say. What else? Family income, monthly income. So what I thought whether any relation is there with the age and degree, you can experiment it, or whether weight and I'll do one thing just like that. As I said earlier, I'll try some wild idea like weight, height and 10th 12th mark. No relation, but still I wanted to just show you what will happen to that. See what is happening. We are not supposed to take this too, but still I thought I will try to show you. What does it indicate? We can say there is no relation. First point, there is no relation between the height of the marks and 10th, 12th, 10th marks, and also it is negative. When it is insignificant, the sign we need not take it seriously. Sign we can ignore it. So which means there is no use of having this relation. Okay. Okay. Then any doubt you want to clarify? A function, I'll try to show that there is a regression. You can click the regression and say OK. Dependent variable and independent variable you need. I will say y as independent dependent variable as this marks, degree marks, and x variable I will try to see whether This degree mark is influenced by age. I'm just at random, I'm doing it. There is no logic behind. I thought I'll try to take it. Okay. A new worksheet I'm showing. If you want any other residuals you want or probability plots you want, you can click here. A simple regression I'll get. Simple regression equation, you'll be able to get it here. Now confidence level, normally we take it as this will give you the range whenever you go for upper boundary and lower bound. It will give you an idea to what extent this can be really adjusted. But you are able to find out the A. It says negatively it is influencing. When you want, it is y is equal to I'm sorry, whenever I put a equal function, this will ask, okay, y is equal to a plus bx. This is the wrong one. I may not be able to use a this symbols here, either equal symbol or plus. So we will say bx. You should be knowing it. Therefore, we can say here the degree percentage is depending upon this intercept plus. I cannot put a plus, you can write it a plus. I'll put within bracket because it's minus, no? 2.798 of age. This is the equation which we are getting it. If you want to write, let me try. After merging it, I'll do it. I'll write here y is equal to a plus bx. This is the formula normally we use. So here, if you want, it will be like degree percentage must be equivalent to 132 132.53 plus minus 2.798 age. Means, suppose if somebody is going to be, what will be the percentage of degree percentage if someone's age is going to be, let us assume somebody's age is going to be, let us say 24. What will be his degree percentage? It is 132.53 plus minus 2.798 into 24, I assumed. You can multiply it with 24. Right. This is the problem. Whenever I put some symbol, it will create a problem. Simply put 24. So what it says is, whenever age is 24, the degree percentage will be 65. If somebody's age is, let us assume, I'm just taking the figure here, 132.53 plus minus 2.798. Let me assume someone's age is 28. Look at what will be the percentage. If age increases, the degree percentage will come down because there is a minus symbol here. Younger age, more possibility for more percentages. That is how we can interpret this. Okay. If you want, you can try with any other figure. Let me try this. I'll delete so that it will not confuse us. Go to data analysis, regression, save OK. Now let me try this degree percentage as a dependent variable. Let me try independent variable. I'm trying to take labels and this multiple regression I have done. Earlier I did a simple regression. Now it is a multiple regression. Now here you may have to be little careful. Earlier I didn't talk about the significance level. I simply took it. But now if you want to form a regression equation, you may have to form it with because many variables are there. All variables are not influencing the degree percentage. So you could find age is this variable you will find is influencing because of the p-value significant 0.05, less than 0.05. Then again 12th mark is having an influence. All of the variables are not. Weight, height, 10th mark is no use. So 12th mark and age are influencing. Therefore, if you want an equation for it, you may have to say degree percentage is equivalent to coefficient to intercept is 112.40 plus it is a 0.034. I am taking only few variables. It is a age plus, I'm extremely sorry, I made a mistake. Sorry, there is a significant value I should not take. I should take the coefficient. It is minus 2.52, 527 I'll take, or 8 I'll take, into age plus 12th mark is significant. Therefore, 0.2243 into 12th marks. I'll simply put 12. That's all. I hope this is visible for you. This is how the equation is formed. Regression equation is formed. Okay. Now, if you assume somebody's age, let us assume somebody's age is 24, what will be his degree percentage? 112.40 plus minus 2.528 into age, as I said, 26, I'll assume, plus 0.2243. 12th percentage, let me say somebody has got 60 percentage. I'll put this within bracket so that 60 percentage, let us assume. See, he or she, if 26 years age, 12th, he or she has got 60 percentage, even in degree they will be able to get 60. That is how we try to form it. So whenever you wanted to form a regression equation, understand that you'll be able to, or you should be able to take only the variables where the values are significant. Insignificant variables like weight, height, 10th marks should not be considered. Okay. Just 1 minute. Okay. Um, anything else? Anything to be clarified?
So there are some budding research scholars are there. So I
I'm sorry?
just want, yeah, I want you to say why we are removing the outliers, why it is important, and why the first descriptive statistics are needed to look into the data and
Now,
and which
outlier, I'm not asking you to remove the outlier. I'm asking you to verify whether the data
verify,
is
yeah,
right.
yeah, verify, yeah.
Yeah, one person,
And how it
what
is,
will
how
happen?
it will, yeah, what happened to the results. And then the second is what type of data for what type of analysis scale. So these three things, if you clarify, then it will
No,
be beneficial.
first point, outliers, if you don't correct or clean, it will create the result what you are going to get will not be correct, representing the population what you have considered. I can, if you want, I can show you what will happen to the average. For example, let us imagine, I'm just trying to take a weight here. Somebody has 200. I think sometime back also I have done it. Now, when I put somebody's age as 200, this is going to be completely away from everybody else. When you calculate the average of it and standard deviation of the entire data, it will give you some figure, but that figure is not going to represent the entire population. this 200 would have influenced and scattered or shown or given the different result. That is, if I remove this data, it is going to be all other data, all other variables or all other items will be of that group. One person will spoil the entire crowd. It's something like that. Therefore, it is better to treat, clean, and then decide whether to remove or not. If data what you have entered is right, then that person should not be part of your analysis. Otherwise, everybody's result will try to go in hayway. Okay, that's the first point. Second, descriptive statistics, as I said, to understand your data, to understand the characteristics, pattern, how the data is, that understanding comes only through the descriptive statistics. I showed you negative skewness. When you have negative skewness, there is a group of people, a big group is moving towards that. So, which means if you go for analysis when you have a negative skewness, definitely it is going to be a problem for you. So, what is expected is we may have to identify the group which is having a high value, either mass or weight or height, and some group which is having a lower value as a two groups, and then analyze two different analyses. Don't combine them together. It is to basically understand the data, basically understand how they are. That is the reason why summary statistics are expected. Yes, ma'am?
Yes, sir.
Yeah.
And the scale and the choice of
Scale
and choice of analysis.
No, I'm not able to understand. No, I'm not able to get it clearly. Now, when we go for, I do not know whether my understanding is right. When we go for this type of, these are all variables. Whenever you go for these variables, we can go for correlation, summary statistics, mean, median, and all we can calculate. Correlation we can calculate. Regression we can go for it. Right? Because these are all definite variables. Measures are there for us. Dummy variable to a certain extent we have represented in the form of a number. It is basically to see whether that male is influencing or not. We may have to go for using that. Whenever you wanted to see the effect of that, we can use it. If you go for a variables like categorical variables, it will be more of string variable. These are all maybe a categorical variables. It is more of string. This doesn't have any value as such unless you represent them in number. So we may have to decide what is to be considered, what is not to be considered, and then try to represent as a number. Categorical variables, you may have to use a either scale. For example, let us say short temper, loving person, lack of knowledge, emotional. We can give a scale for it. To what extent they range it. I didn't get a scale here. I simply got the temperament, how they are looking, how they feel like. That's all. Now I can put either yes or no only. I cannot go for putting a scale 1 to 5 or 3 to 6. We cannot do it because I need to identify from them directly whether they are in the middle level or high level or low level. So that is the time when I use a scale, then I can do it accordingly. Okay, ma'am?
Yes, sir. Thank you.
Okay, some basics. I'm sorry I started late, therefore I don't want to hold long time. So I can maybe think about one more session, maybe advanced statistics, maybe another tool I can introduce. We can
Yes,
think
sir.
about if they are interested, we can think about it later.
Yes.
Thank you, ma'am.
Preeti?
Yes, ma'am. The entire Department of Commerce and then Madras University Commerce Alumni Association, I would like to thank sir for the wonderful session. From the basics till the advanced level, you taught us how to move on with the Excel. We got used to like SPSS, and now this Excel session was actually an enlightening session for us. So thank you very much. We are very much grateful for your presence, sir. Thank you.
Thank you. Thank you. All the best to you all.
Thank you very much, sir. Thank you so much,
Thank
sir.
you, sir.
Thank you. Bye-bye. Bye.
Thank you, sir.
Okay, ma'am. Shall I exit?
Yeah, thank you, sir.
Thank you, ma'am.
We request the participant to wait for a few minutes. We'll share the certificate link in the description box. So kindly fill the certificate. Kindly fill your Google form link so that you can receive the certificate immediately. And we are not posting this web link, Google form link in the group. So the participant who is currently present right now have to fill it immediately. And this link will be open only for an hour to max 1 hour. Make sure that you fill this Google form immediately. Thank you. And you can also subscribe our YouTube channel, which has been streaming right now. Thank you for this wonderful session. Thank you all. So kindly check your description box. You can find the Google form link. So I remind the participants once again that this link will be open for 30 minutes, max 1 hour. And we will not post this link in the group. Make sure that you fill this form immediately. Sure.